This is my presentation for the final project of computational geometry, and my project is the implementation of ear clipping triangulation in processing and p5.js. So, introduction. This project tries to look at the time it takes to run the ear clipping algorithm in two different programming languages. The first programming language is processing, it is based on Java, and the second one is p5.js, it is based on JavaScript. So, p5.js and processing are developed by the same organization and they have similar functions. P5.js canvas is run in a web browser, whereas the processing canvas runs as an application. Since P5.js canvas is run in a web browser, it has an additional file called index.html, and processing does not have that. So the ear clipping algorithm implemented in this project has a time complexity of O of n square, and it achieves this by taking advantage of an array to keep track of all the vertices to see if they are ears or not. So how does the project work? The exact same algorithm has been implemented in both programming languages, and the user has the option to create polygons by clicking on the canvas or by specifying the number of vertices and generating a random polygon. So once the polygon has been created, the user can test how long it takes for the algorithm to run 10,000 times by pressing T. Once the algorithm has ran for 10,000 times, the program will let the user know how many milliseconds it took to run. This helps us to see the difference in time it takes for different programming languages to run the same algorithm, and all the challenges that come with trying to write the same code in two different languages. So if we try to run the sketch that I have made in processing, this is how it looks. The user can add points by clicking on the canvas, and it adds a point wherever the mouse has been clicked. We can also clear the polygon. We can create a random polygon by specifying the number of vertices by pressing plus or minus. So let's try to create a polygon with 20 random vertices. So 20 and G. So this is the polygon that we have that we got. So it has 20 points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the polygon is always counterclockwise. So this is the triangulation that the algorithm has given us. And if we press T, it shows us how long it takes for the algorithm to run 10,000 times. So this is the testing part. So it starts a timer, it runs it for this many times, and once it has been run for 10,000 times, it stops the timer and then prints out how long it took for the algorithm to run. So okay. Algorithm explanation. The ear-based triangulation's main idea is to first locate an ear, output the diagonal, and then clip the ear. This will be repeated until only one triangle is left. This method, if implemented naively, it will take O of n cube time to run, but if the algorithm has a list of ears that is updated continuously, then it comes down to O of n square. So first we make a deep clone of the vertices. We then classify the vertices as a convex or concave ear vertex and keep them in a list. And after we have the list, we iterate through the list and check to confirm that the vertex is an ear. If it is, we cut the ear and continue. So, okay. And this is the main function of the algorithm. So we create an array of vertices, which is a copy of all the vertices in the polygon. And once we create the array, we classify all the vertices as convex or concave and stored it in an array called vertex types. Once we have the list of all the vertices and if they are ears or not, we then iterate through all the points and check to see if it is an ear. If it is, we cut the ear and then continue iterating. So once we are done with the iteration, we will have an array of triangles which is generated by the cut ear tip. So if it is, so this algorithm adds triangles to the array, and it returns the array of triangles. So the whole algorithm is somewhere about 200 lines, and it is the exact same algorithm that is implemented in the other in Java processing too. So it is the exact same algorithm. Okay. So testing differences between p5.js and processing. To test the code in both languages, it is the exact same method. When the user presses T, the function testing time is called. Inside the function, we start a timer and run the application. Once it runs 10,000 times, the program will print out the amount of time it took for the code to run. This can be tested with many different kinds of polygons. The user can create their own and test it, or they can generate a random polygon with the number of vertices specified. The time difference between the two polygons is not a whole lot, but processing is 30 to 50% faster than p5.js in some conditions. So let's try to create another polygon that has 20 different vertices, and let's try to test it. So this algorithm for 20 different vertices is taking us about 50 milliseconds to run every time. So if we go to p5.js and run it, so this is how it looks. Inspect. Oh, see. So let's try to create another polygon that is 20 points, 20 different points. G. This is the polygon that has been created. So it is the exact same thing. 1, 2, 3, 4, 5, 6, 7. It is counterclockwise, and this is the triangulation that we have. So if we try to test it, open the console, test. Oh my god, C, G. If we try to test it, it takes 74, 74, 76, 70, 77. It takes around 75 milliseconds to run the exact same algorithm. So there is a difference of 25 milliseconds between processing and p5.js. So conclusion. The goal of this project was to run the exact same algorithm in both programming languages, and it was succeeded. The data structures used are also almost the same, except that in JavaScript there is no way for the developer to specify the type of the variable. The lists in JavaScript are also different compared to the ones used in Java. We can only use arrays in JavaScript. The point class is implemented using a vector in p5.js. Since there is no support for p vector in JavaScript, a lot of workarounds have been made to make the code in JavaScript run, as the syntax and the libraries in JavaScript are limited. Finally, the time it takes to run the algorithm in Java and JavaScript is different, with Java being 30 to 50% faster than JavaScript. So in the demonstration that we had over here, it took around 50 milliseconds for processing to run 20 points, and took around it took 75 milliseconds for p5.js to run 20 vertices. So that is a difference of 50%, and that is a huge difference. So that is the end of the presentation. Thank you.